Hello everyone, this is Asim, and today I'm going to continue with the GraphQL series. We have been seeing this exploitation in the past three parts, where we first set up the GraphQL exploitation and then we tried to exploit that application, which was a damn vulnerable GraphQL implementation. In this part, we'll see the deep recursion attack, and we'll also see how we can use introspection query to dump the whole schema. We'll do this, and that would help us to also visualize the whole schema, what are different types and queries in the backend. I'll use the GraphQL OJ for that. We'll continue this series and we'll try to explore all the different GraphQL exploitation using that application itself. So let's get started. So here we have the damn vulnerable GraphQL application, and let's come to the scenarios here. These are the scenarios here. So we'll be covering this deep recursion attack and also this GraphQL introspection. Let me show you how we can start this Docker server. So this is the command here. I'll paste the command in the description as well. And because this image is already downloaded on my machine, so it won't be pulling it again. Let's refresh this. Now it's running. So if I refresh it, you will see this application here. In the later parts, we'll also try to do a proper pen test of this application. But for just to understand the vulnerability in GraphQL applications, we'll just explore those two things. So let's see. Let's first try to figure out the GraphQL endpoint. We already figured it out, but let's again do this. So I'm just enabling my proxy here. Burp for all proxy. I have my burp here. Yeah. Let's clear this first. Clear history, yes. Now let's start public paste. Let's say I'll try to get the public paste. And there's this get endpoint, there's a post endpoint and all this. So let me just send it to the repeater. So if I send here, you will see that there's this query get paste, and this is where we are getting the paste, the different kind of paste, the ID part, the title and all these things. And this is the same that we see here. So let's try this introspection query. This introspection query basically helps you dump the whole GraphQL schema, and we get to know what are the different values here. Like we see only these values here. We see only these values here, but there could be many other sensitive values. So that's what we are going to try here. Let's copy this here and paste it here so that there is no indentation issue here. Let's see and paste it here, query introspection query, and this would help us get all the mutation, all the queries, all the variables and data endpoints that are there in the schema itself. It takes some time. Meanwhile, let me just show you how we're gonna visualize this. So this is a GraphQL voucher. I'll add the link for this in the description as well. You'd see there's this GraphQL thing. It's some default GraphQL thing. You can change the schema here. So the schema is basically kind of how the backend is, how the different attributes or different properties in the database would look like. It's not exactly a replica of database, but that's how the GraphQL is structured in the format in the backend. So there's this root file, there's all films, then there's a single film and all these kinds of things. So if I had to change the schema, let's say for Shopify's storefront and display, then it might be like this. Like there's a customer, there's a shop, and the customer has these attributes like addresses, created at default address, display name, email, etc. So the same thing could be here that, okay, let's first copy this to the bottom. Yep. So the same thing could be here that in the owner there could be maybe email addresses and address and all those kinds of things. So maybe we can just add a parameter here, email, and then we can get it out. So we need to figure out what are different values that are there. So we'll be using this. In the introspection tab, just paste the introspection response, whatever you got, and you see this is the whole schema of it. So there are different kinds of queries. There's paste. Paste is an array of paste object. This is the paste object, and paste object has ID, title, content, public, user agent, IP address, owner ID, and that's what we see here: ID, title, content, IP address, user agent, and then there's this owner type, which is again linked to this owner object, which is this ID, name, paste, and then it's again linked back to the paste object. The other object, there's this users, which has username, password. There's this me object, which is also linked to this user object. There's an audit object which has GQL operation, which is GraphQL operation, GraphQL query, timestamp, what timestamp the particular operation was done. Probably it is being used to audit the application and see if someone is running some malicious query or not. There's this read and burn thing. It again uses this paste object to create this paste object. Users, again, get the users. There are different system queries. We will be exploring this in the next part, where we'll see how this would help an attacker in their malicious intent kind of thing. For the purpose of this video, we'll just focus on this particular thing, the paste object and the owner object. You see here there is this circular loop kind of thing. There's this paste object which references the owner object. There's this owner object references back to the paste object. So you can see there's this circular loop kind of thing. So if we query paste, we also get owner. If we query owner, we also can get paste. So you can imagine, let's say it's a recursive query, paste owner, and then it would basically help the GraphQL server would get overwhelmed around it. So that's what the idea is. First, let me show you a simple query here. I already have this query, I think. So let me just check once. Yeah. So this is the whole query. Let's just take two parts of it and show you how that goes. So there's this owner. What field does owner has? The name and paste, right? So let's say name, closing all the brackets. So let's copy this and try it in verb. So query. We can't paste it like this, so first we need to normalize it. I mean, proper indentation. So usually I paste it in the address bar of it and just send it. So it's a query paste owner name, and then again owner name is the same thing. So all the paste by the owner DVGA. So this is just single nesting. If we increase it a lot, you might see there's like the content length currently is 81 and it took a small time, but if we increase this in a very bit, we might see a large thing happening. Denial of service kind of attack happening. So let's say this is the paste here, and let's paste it here. Let's see how deep this goes and how many recursions happen. So you can see it's 3367, and this is the whole data of it. If you see, we can also increase it to whatever length we want. It's just that we need to let's increase this length to, let's indent it properly. I think, yeah, this would be good. Let's match the brackets here. Where the brackets, so this bracket would match here. I think every bracket is accounted for. Let's try it here. We'll see if something goes wrong, but let's try to get this thing. You can see it's taking some bit of time because it's nested query and it's a recursive loop. So that's why it kind of a denial of service where it takes a lot of time for this to process. We'll see how long it goes. You can see it's 27,111 bytes. It's a huge amount, and it also took some time. If we run it through, let's say, copy as Python request, I'll just copy it as Python request, and I think okay. So what I'm gonna do is I'll just run this as I'll just show you how much time it takes, import time, and start time equal to time.time, print took and the time I start time seconds. So let's run this now. I have an IPython shell running, perhaps. Okay, not. Let me just open IPython 3. I prefer IPython because it's a bit formatting is a bit good, that's all. So this is an extension. I've enabled it here in extender, copy as Python request. So it just helped me copy any of these requests as Python request. So it's a bit easy if I have to do some manipulation using automation and all those kinds of things. Let's see how long it takes. It took 17 seconds. So you can easily understand it could be a grid analysis coming the same request from hundreds of different endpoints. So yeah, that's pretty much for this. Hope you like this. I'll continue making this series and we'll be following all these scenarios mentioned here. And we'll try to cover almost all of these. It would be like a 4 or 5 more videos. Make sure you stick by. Have a nice day.